Well, hello. How are you, Joe?
Great, Beth. And you?
Great. I just wanted to introduce myself. My name is Beth Reilly, and I am with the Flamingo Group, and I'm a realtor. And our team has been very interested in the building of green homes. And the start of this is with Joe Pasma from Enercept, and he's the national sales manager for the Enercept Incorporated. I have lots of questions for you, Joe, but if you'd like to start, just tell me a little bit, or if you could tell the audience also a little bit about what SIPs is and what Enercept does.
Well, Enercept is a manufacturer of structural insulated panels. So SIP is an acronym for structural insulated panels. And what that is a combination or a layering, if you will, a composite of oriented strand board. Those are the skins. The OSB
Mhm.
and that stands for oriented strand board. And then we use an EPS foam core. EPS stands for expanded polystyrene. That's the same type of insulation that you use in a foam coffee cup or when you get your leftovers, the clamshells that they
Yep.
provide from the restaurants. Same type of material. And what we do at the plant then is add an adhesive that glues the OSB skin to that EPS core. So we end up with a composite panel, sort of like an Oreo cookie, if you will, the vanilla version of the Oreo cookie.
Mhm.
We can make the panel in sizes up to 8 feet by 24 feet. Those are the largest pieces of OSB that we can get. And that then is one solid piece that can be used for walls and roofs. Now, typically, you're using the panels for the exterior envelope of the structure. You want
Okay.
to use it from the standpoint of insulation. If you think about us on these cold Minnesota days, we go outside and we put on clothes on the outside, we put our hat on, kind of a thing. Well, the SIPs, if you will, do the same thing, but from a building standpoint. You're using those for that exterior envelope of walls and
So it
roof.
would not be on the interior at all then for obvious reasons. It's insulated.
Correct.
Yeah.
Correct. We would stick frame the interior walls so that the mechanicals can be run there. So we're optimizing the energy efficiency of that exterior shell by using the SIPs.
So what I noticed too is that right next to the EPS, the little tag right there on the slide, there's a hinge on it. What is that used for?
It's actually a chase that's cut into the foam core of the panel. That's an electrical chase. So
Oh,
we'll
okay.
put electrical chases in the panel that run typically on a wall. They'll be spaced 4 foot apart and they'll run vertically from the top of the wall down to the sill plate. And then we'll also have horizontal chases at switch and outlet heights so that when the panels are all assembled, you have these chases that we can put the wiring through. So it makes wiring from an electrical standpoint relatively easy. And then as the panels are installed in the field, they will drill the top and bottom plates to be able to access those chases.
Okay, so maybe we could back up a little bit. Could you tell me a little bit of how this is installed? Because when we first talked about it, these are good videos for this or good pictures for this. But when we talked before, you said it's kind of like putting together Legos.
Yes, what you see, the center picture is a good example, or the one on the right is a good example of that. The panel itself will, at the factory, will shape the panels so we'll laminate the panel first. And then, depending on where it's used in the structure, it may be just a rectangular piece, or you can see in the right hand picture on the gable ends, the triangular piece that makes that gable end. We can actually cut that shape into place or into the piece of the panel itself. And then the lifting devices, you see telescopic handlers
Mhm.
dropping the pieces into place. So, really, it does become like a giant Lego set that you're putting together in the field.
Wow. So basically, you make a design ahead of time. The design probably is pretty important because then you're going to cut out all the different panels and put them together to create the house. Is that correct?
Yes, and that's one of the things. The one of the buzzwords in today's building environment is offsite construction and panelized offsite construction. Well, it's pretty easy to see in the middle picture and again on the right hand side the panel itself as it's hanging or sitting on that lifting device being put into place. So that's the panelized side of that. The off-site construction comes from the manufacturing and the shaping of that final laminated piece that we do at the factory. So we'll use typically a 6-inch panel, a nominal 6-inch panel for the walls.
Mhm.
And roof panels, it's hard to see in the picture because it's relatively small, but on the right-hand side, that's probably a 10 or a 12-inch thick roof panel. And then as the panels differ in thickness, so does the R values. And those R values then are determined to match the energy codes that we have to build by. So here in the Minneapolis area, Minnesota, we're typically looking at an R21 for the walls. Well, the SIP panels are about an R22 to R24, and the roof panels, that 10-inch panel is an R38, or the 12-inch panel is closer to R50. And again, the two things from a roof panel standpoint that you take into account are the R value and the structural strength itself. So you can see in that right-hand picture, there's a ridge beam up at the top of the gable. So the roof panel can span from that exterior wall all the way up to the ridge, which then makes for a vaulted ceiling. And it opens up the space inside the room for that. And again, you can see that the panels then are used for that exterior envelope of the building.
Okay, maybe we can get a closer look at that just to see what that looks like. I guess not. It's in the third one, the third panel on the right, or the third picture on the right, if that could be expanded at all, just so it's easier to see. So basically what you're saying is the walls are a little bit less insulated than the roof is.
Yes, and that matches what the energy codes show. They have the building codes have a prescriptive methodology. They dictate or show us what that insulation value should be, and then we match that with the panel based on where it is that you're building. If you go up to the far northern parts of Minnesota, that R value may be required to be a little bit higher than down in the southern part of the state.
How much does it cost? Now, one of the things that you talked about in our previous conversation was just the big difference in what's going on now that we're trying to go green. Thank you. Now that we're trying to go green, or we're very conscious of going green more than we were maybe 3 years ago. Where is it going? Like before, you said that houses have been built exactly the same for like 150 years. Could you go on the history of what's went on with sticks, and now we're going to panels and building like Legos? What are some of the things that you just, if you could shed a little light on that?
Well, with the panelized construction, what it does is it removes a lot of the thermal bridging that we see with stick frame construction. And that's where the energy codes are really pushing to minimize the amount of material that touches the inside of the building as well as the outside of the building. And if you think about stick construction, or even in the picture on the left-hand side, right below the gable in the picture, you can see that there's a mullion there for the window itself, and that's touching both the inside and outside. Well, when you do that, the wood itself has less R value than that foam insulation. If you think back to that foam coffee cup that you guys have when you go to the restaurant or wherever, there's only 1/8 of an inch of thickness of that material, and yet the water or coffee that's in that, or tea or beer, I guess you're not drinking beer out of a coffee cup, but the hot coffee at 200 degrees doesn't burn your fingers. Well, the same kind of thing happens with the house itself. So by putting the foam in between and minimizing the amount of material that touches that inside skin and the outside of the building, you reduce that thermal bridging. So with that in mind, the SIPs, you can set them in place, and it does that. Most stick construction, they talk about having a 25% framing factor. That means when you look at a wall, you see about 25% of that is solid material touching the inside face and the outside face. SIP construction is down to about 3 to 5% of a framing factor, where you have material touching both the inside and the outside of the building. And that'll happen like the windows, your sill plate at the bottom of a wall, at the top of a wall, or the eye joists that you see in the side of that roof panel hanging off of the telescoping handler as it's being set into place.
So when we're doing this and when you're doing this construction, are you using regular windows? Are you using shingles, or is everything
Yes,
else the same?
absolutely. Everything is the same. And the cool thing about SIPs today, as the energy codes are evolving, they're talking about a thing called continuous insulation. And they realize that thermal bridging that's occurring from the inside to the outside is reducing the energy efficiency of the walls and the roof of our homes. So what the building codes are mandating is that we put a continuous layer of rigid insulation on the outside of our walls. And they want that to be 1.5 to 2 inches in thickness. So now when you think about a stud wall, a 2x6 stud wall that's 5.5 inches thick, and you put your sheathing 1/2 inch on the outside of that, you got a 6-inch thick wall. But now you have to put another layer of 1.5 to 2 inch insulation on the outside of that, which means that when you put in your windows, now your that jamb extension has to go to something close to 8 inches. With the SIP panel, you get that same energy efficiency, but you don't have to go through those extra steps of putting that rigid insulation on the outside of the walls. So it really simplifies construction from that standpoint. And that's where that less labor comes into play. You can see or
And they don't have
realize.
to be on site, meaning going to all the different sites, and to do that, could you less labor? Yeah. So that would be, how much does it cost to build a SIP building?
It's very
Uh,
similar in
yeah,
it's
approximately.
it's very similar when you look at the final price of the house. It's very similar to stick frame construction. Actually, it can be a little bit less because with the building being so tight and energy efficient, you can start to downsize your mechanical equipment. So that means you can have a smaller furnace, a smaller air conditioning system, which costs less, which use less energy. So in the end, what you're paying on your mortgage is actually less than if you'd built a stick frame home. Because now, one of the things that a lot of people will consider is if you just have a pile of sticks sitting on a job site ready to be put up and the panels put up, the panels are going to cost more. But the reason for that is they're already insulated and you don't have to apply all those other materials to it. You set them in place and finish them.
And that would be a good segue. So from the beginning to the end of construction, in the sense that it's time to put the panels on, well, you still need the foundation put in. About how long does it take?
Obviously, it's going to depend on the complexity of
Nice.
the house. So when you look at like the one that's on the screen, that's going to take a little bit more time than just a simple box. But if you compare a stick framed home and a SIP home of very similar layouts, the SIP frame home is going to go up about half the time.
In half the
They
time.
just, and if it's a real simple box, now I'm going to talk really simplified. So,
A
say somebody
square.
wants, like somebody wants to put a hunting shack up in northern Minnesota. We take those 8 by 24 foot panels. You could have 4 of those laid down so that the walls are 8 foot tall, 4 panels, and your walls are all up. And you could put 6 or 8 panels on the roof, and the roof is enclosed. You could actually do that in a day's time.
Okay.
Which stick framing is going to take you a week or two by the time you cut all the studs and insulate it all. So that's way oversimplified, Beth, but it does give you an idea of that snapshot of time savings that you can realize by using SIPs in the
Well,
construction.
just to have to, and we put the labor slide up. First of all, I love that house and it's beautiful. And I want people to know that you can build a beautiful house with this type of construction. The other thing is the less labor really lies in the fact that this can be what was the word you used? Pre-manufactured. What was it?
Yes, panelized offsite construction. That's
Offsite construction. Because then there's so many issues right now to get people to the sites.
yes,
We're
especially
okay.
now in the wintertime. You got to fight all the snow. So, if you get a window of 2 or 3 days where you don't have snow, clean the site off, clean your foundation off, you can actually have the walls up and the roof on and the building enclosed. And next week you throw a small heater in there and you can start to finish off the inside of the building very quickly.
Which is always a trick. I mean,
Yes.
you want to keep people working the whole year round. So that's always a trick. That's why I work with a lot of different builders that will try and flip just for the winter. They might not make any money on the flip, but they're going to keep their teams. So
Yep.
this might overcome some of that. The other thing is really we talked a little bit about the design. Could you go into it as far as the architectural design of a home? Does it need to be specific to SIPs? Tell me a little bit about that.
No, it doesn't. And what we do at the plant is take plans that are designed with sticks in mind, and we convert that to panelized construction, to SIP construction. Now, one of the things that is a little bit more onerous, if you will, with SIP construction, when you look at the picture that's up on the screen, you see a lot of the windows, the doors and the windows and the rough openings. Because we're prefabricating and cutting those doors and windows into the panels at the plant, we obviously need to know what size that means. They need to be cut at. That means that the building owner or somebody needs to decide what size rough openings we need. They need to let us know what that is so we can cut it. And then when we put it together, or when it's put together and assembled in the field, the windows just slide into those openings. And that's not to say that we can't cut the openings in the field, but that idea of using the factory, that controlled environment to manufacture the panels really pays off from that standpoint. So
And the precision.
you'd mentioned earlier about the foundation needs to go in. Well, one of the cool things that can happen, and you can press that on-site schedule, if you will, is that while the foundation is being installed, we're manufacturing the panels at the plant so that once the foundation is done and the timing is right on site, the truck rolls up with all these big pieces and the Legos are put in place and the building goes up that much faster.
Great. How easy is it to fix this type of a structure?
It's wood-based technology. So it's the same OSB sheathing that we use on stick frame construction that we use with the SIP panels themselves. So if there's an issue, a storm comes up, a tree falls on the panel, whatever, that can be modified and fixed just like you would with stick frame construction. Obviously, it's going to depend on the extent of the damage that's done, but it can be fixed or remodeled just as easily as stick frame construction.
Okay, and of course, you get involved with that. It goes back to your manufacturer. It starts over.
Yes.
With that, you had mentioned too something about storms. Could you tell me a little bit about how this construction is different than sticks and how, let's say, storms, high winds? That was an interesting analogy and just, I don't know, food for thought.
If you think about stick frame construction and all of the studs that go in the walls, those are all nailed in place. And those nails and that connection is almost like a bunch of hinges, if you will. And when the wind blows, those hinges, or think of straws, playing with Legos and kids playing, making little buildings, if you will, out of straws. They're really wobbly kind of a thing. And so with stick construction, they put the sheathing on the outside to stiffen everything up. Well, with SIPs, we have 2 layers of sheathing already on the panel itself. So once the walls are put in place and the roof is put on, it's very similar to, I guess the analogy I used before is if you think of a book and the front cover and the back cover, and you can rotate those with respect to one another. They slide and twist back and forth. That's sort of the way the stick frame building works. But the SIP, if you think of a box, stuff that we get from Amazon, and those are all taped on the edges so that all 6 sides of that box are tight together. That's what we do with the SIPs as we fasten them together. So when you try to move one face with respect to another, they don't, and it becomes really stiff that way and very strong. So wind events, tornadoes, high winds, storms, the panels do a really good job of resisting.
There's a little more resiliency.
Yes, very much so.
Excellent. Um, is this available? Is this technology something that's being used internationally? And if it is it being used widespread, and which countries? Things like that. A little background on that would be great.
It is used internationally. We as Enercept have shipped all over the world. We have projects that have gone down to the North Pole as well as the South Pole. The Arctic station that they have down in the South Pole um, are Enercept panels. But
Interesting.
England and Europe has SIPs, and they've done a lot of work with that. In fact, there's an ISO standard, ISO. It's sort of like our ASTM standards here in the U.S. that is an international standard. So yes, there are other countries that are also using SIPs. We don't get involved specifically sending or competing with them. There's enough work going on in the U.S. that we focus on that. But it is something that a technology that is being used worldwide. Yes.
Excellent. Of that. Oh, and then Joe, also you have a PE after your name. Could you give us a little bit of a brief of what does that mean?
That stands for professional engineer, which means I'm a structural engineer by training. So in order for me or the building codes to accept a structural design that I would work on, I have to be licensed. And I have to be licensed in the state that that building is being constructed in. So by putting that PE shows that designation, and I'm licensed in 6 or 7 states.
Excellent. You must like this technology.
I do. I got started with it back in '92, and I've spent 10 years in the Twin Cities area, actually just doing installs of basements and exterior shells, and then turning the product back over, the building back over to the homeowners to finish off. And then I've worked and done a lot of technical support work for the various manufacturing companies that I worked for. And now I support our sales team as the national sales manager at Enercept. And I believe in the material, I believe in the product. Back in 2002, my wife and I did an addition on our house in White Bear, and we went from 1,800 square feet to 5,000 square feet under roof. It happens to be Enercept SIP panels.
Okay.
And when we did that, our energy costs didn't go up. Obviously, our bills now are more expensive than they were back then because of the price of gas and heat. But comparatively, when we did the addition, we didn't see any increase in our utility bills through, well, then it was NSP, now it's XL. But I think that to me is a living testament that the panels are very energy efficient.
Excellent. The other thing we didn't talk about, at least not yet, is you talk a lot about efficiency, air efficiency, things like that. Could you talk a little bit about, because I know whenever anybody hears airtight and clean air and all that, they really want to know what is the airflow in something this well constructed and closed in.
From a building science standpoint, the buzzword, I guess, is build tight, ventilate right. And what that means, if you think about back to that stick frame building and all of those joints, and you go to St. Paul, the Summit area, and the old brick buildings, they're real leaky and drafty. And it's so what do we do in the wintertime to take the drafts away from our windows? We get that 3M clear plastic and we stick it on our windows and use the heat shrink to tighten it up. And what we're trying to do when we do that is eliminate the air leakage that's occurring at that location. So with SIP construction, and really with any high performance construction, whether it's stick construction or SIP construction, that's really what's happening in SIPs. As we put those together, we use a sealant between the joints of the panels. And then on the interior side of the panels for the walls and the roof, there's a tape that goes over that. And what that does is it minimizes any air leakage that occurs. So in reality, it's like making a baggie. The house becomes a baggie, if you will. Well, that in and of itself can be a problem because we as people, we bathe, we breathe, we
Hmm.
exude moisture. That's
Right.
that issues that you're talking about from a moisture standpoint. Well, what we need to do to minimize that is to put in air exchange systems, a ventilation system. That's the ventilate right side of the building science acronym, if you will,
Hmm.
or building science philosophy. So you have them, you've tightened the envelope up. Now you put in a mechanical system that can draw fresh air from the outside and exhaust stale air from the inside. And not only is the air stale, that's exhausting, but we're trying to keep the moisture content, our relative humidity in the wintertime, down to a manageable level so that we don't get condensation on our windows and those kind of
Right.
cold
Right.
locations. So again, the insulation being thick enough that you don't get condensation in that because it's
Mhm.
solid, there's no airflow in there. That's what that sealant and tape minimize. So then now it becomes a real comfortable living space. And you can also then, as you bring in that fresh air, you can filter it. So if it has allergens in it or things that we as people don't agree with, that filtering, that mechanical ventilation side of it and the filtering makes it a very comfortable,
Easier to manage, actually.
yes,
Mhm.
almost a safe haven, if you will, depending on the time of the year, that we all suffer from hay fever and allergies and all of those
Right.
kinds of things.
I like the build right, ventilate right. Build tight, ventilate right. That's a good thing to kind of keep as a buzzword. Also, what are some of your pet other green heating sources that you think really go well with SIPs, or that you've actually done jobs on and you're like, this rocks. This is a great green source of heat. Or
With from a lighting standpoint, one of the things, with the vaulted ceilings, a lot of people talk about want to have can lights. I
Mhm.
think one of the and can lights with SIP roof panels don't work well because you're cutting a hole in that insulation and you're also compromising some of the structural sides of that. So the advent of these new LED thin low profile lights work really cool from the standpoint of
Okay.
the vaulted
Things
ceilings
like that.
and
Yeah.
what that can show. So I think that works really cool. From a heating and cooling standpoint, you can really use any type of equipment that's out there. The challenge with the SIP building or any high performance building is that you don't need as much heating at this time of the year.
Right.
40 or 50,000 BTU furnace is a relatively small furnace. Well, a 2,000 square foot home might only need 15,000 BTUs. How do you do that? Well, mini splits become a really cool way of
Oh, okay. What they use
taking
throughout
care of
Europe. Mhm.
that kind of situation. And we see a lot of that kind of stuff happening, around the cities here. So mini splits work well. You can do the geothermal, but that gets to be depending on where you're at. Drilling wells might be a bit of an issue from that standpoint. There a lot of things are changing and moving to air source heat pumps now. So you're using that for cooling and heating, and the efficiencies of some of that equipment are to the point where an air source heat pump can actually heat a building even if it's -5 degrees outside. So there's some really cool technologies, and that those technologies can be downsized, which again changes that cost structure of the building. And so maybe you pay a little bit more for that envelope, but you're paying less for the equipment that's heating and cooling it. So in the end, you end up with a much more comfortable home that actually costs less.
Yeah, my pet love is in-floor heating. So,
Those radiant heating
love it.
is fantastic.
It's really nice heat because
It
it's
is.
so consistent throughout the whole house. So that's my creature comfort that I like.
I just learned of a mirror that it works on a similar principle to the radiant floor, but it's a radiant heat source. So the mirror actually heats up the objects in the room through radiant heat, And
Wow.
I'm told that that's really comfortable too. That was my reaction, Beth, when I heard about it. Is wow.
Yeah, that's a whole new webinar, I think.
Yeah, and I don't know much about it at this point in time. I need to do a lot more research on that, but it sounds really promising from that standpoint.
Well, Joe Pasma, this has been a really great overview of Enercept and how SIPs works, and also the new green structures that are coming down the line. And just, I think it will be a series of things that will slowly educate the public to start seeing these as great options for either an addition on their house or a new build, of course.
I agree, and um, I'm maybe a little bit goofy since I've been in this industry for 30 years and have seen the advantages of it for that length of time. It's really cool to see. So it's not new technology in the sense that it was just developed yesterday, but I think we're coming together both from an energy code standpoint. People are really concerned about carbon footprints and what we're doing with the environment, and I really think that SIPs offer an advancement or a different way of looking at how we put buildings together that makes a lot of sense. And I think it's great that that time seems to be happening now. And I really think they're going to expand a lot in their usage and the familiarity of everybody that's out there.
Thank you. So if you do want to learn more about SIPs, Enercept, and this technology, or you're actually in the process of building, Joe would be a great resource. And we do have right down below there, we have the link to your company. Thank you so much.
Thank you. Enjoyed being with you guys.
Yeah, thanks again.